Today we're going to be looking at factor by grouping, and our goal is to use the method known as factor by grouping to factor polynomials. Now the polynomials we're going to be looking at today have no pre-existing common factor. So even though in yesterday's lesson I told you that the greatest common factor is the first thing that you're always going to look for, I've engineered these problems to where all of them have no common factor. Right, so there is one completely worked out example here, and we're just going to talk through it, and then we'll do a few where you can see it happening. So first we're given a quadratic trinomial. So here's our trinomial here. Your first step to use this method is to multiply together the first term and the last term. So 3x squared times 2, and we get 6x squared. Next, we're going to find all of the factor pairs that make 6x squared. The x squared we're going to split up to each of the factors. So it'll be an x with one of them and an x with the other one. So our factor pairs would be 1x and 6x, as 1x times 6x would be 6x squared. And if I add those together, I get 7x. So what I'm doing here is making factor pairs, and I'm summing them. The next pair, 2x plus 3x, would be 5x. Then we could also have a negative 1x and a negative 6x, because if you multiply a negative and a negative, you do get a positive. And when you add those together, negative 1x plus negative 6x, you get negative 7x. And we could also have a negative 2x times plus a negative 3x. Negative 2x times negative 3x makes the positive 6x. Negative 2x plus negative 3x makes a negative 5x. So from these, we're going to choose the sum that gives us the second term of the original trinomial. So going back to look, my second term was positive 5x plus 5x there. So this is the pair that's going to work. So our next step is to replace the middle term, the second term, with the sum that we found up here. So the one that we have highlighted there. So now it says 3x squared plus 2x plus 3x plus 2. Now it's important to note at this point that the two terms here in the middle, if we did combine them, would be 5x, which means the expression that we have right now is equivalent to the original one that we have. We just kind of changed the middle term a little bit to make it more friendly for what we need to do. The next step is to make two groups by putting parentheses around the first two terms and putting parentheses around the second two terms. And there has to be a plus sign between them when you do that. So there must be a plus sign in here. If there's not, we have to create one. And we'll look at that in some of our examples later. Next, we're going to find the greatest common factor in each group. So this is using our lesson from yesterday. So in this first group, the greatest common factor for these two terms would be just an x. Sorry, that was one of my dogs. And the greatest common factor in the second group, since these two have no common factors, the greatest common factor would be just a 1. Now, factor by grouping only works if once you've taken out the greatest common factor from each of your little groups, the two things that are in parentheses here have to be identical. And in this case, they are. So we would call that a common binomial. So we're going to factor out that common binomial. That comes right here. That's like the greatest common factor of this thing and this thing. So the 3x plus 2 is what they have in common. When you divide each of these by 3x plus 2, you end up with x from the first one and a plus 1 from the second one. So x plus 1 is the second factor there. And this is now factored. All right, so now we're going to look at factoring each of these quadratic trinomial expressions using that very same method. So for our first one here, our first step, and I'm going to do this out to the side, just to conserve space underneath here. This part should really be done out to the side because in all actuality, it is scratch work. It doesn't really belong in line with your work. So we're going to take 4x squared and multiply it by 6. So that's multiplying the first term and the third term together. When we do that, we get 24x squared. Now I'm going to make a list of factor pairs here for 24x squared. We'll start with this. So, okay, 1x squared, and then we're going to be adding those factor pairs together. So plus 24x squared, and that would give us 25x squared. Oops, this is not right at all. Let me try that again. The square should not be on there. So this is 1x plus 24x. 1x times 24x would be 24x squared. 1x plus 24x gives me 25x. I'm looking for a pair that gives me this term in the middle. So once I find that pair, I'm not going to continue with this list anymore. My next pair would be 2x plus 12x. 2x times 12x would give me 24x squared. And if I add them, 2x plus 12x would give me 14x. And again, I'm trying to make 11x, and I don't have it yet, so I'm going to keep going. 24 is divisible by 3 also. That's 2 plus 4 is 6, which is divisible by 3. So 3x plus 8x. 3x times 8x is 24x squared. 3x plus 8x is 11x. And 11x is what I was trying to create. It's a positive 11x. So I actually don't need to go any further. There are many more factors for 24x squared factor pairs, but I don't need the rest of them. I've already found the one I need. So I'm going to go ahead and go back to my original problem here. Go back to a different color now. Okay, so what I do with those numbers that I just found is I'm going to rewrite this middle term. I'm going to replace it with what it's equivalent to. So this is 4x squared plus 3x plus 8x plus 6. Now, once I've replaced the middle term with the expression that I came up with in my scratch work off to the side, my next step is to group together the first two terms and group together the last two terms, making sure that there's a plus sign in between the two groupings. In the first group, the greatest common factor is x. So we're going to factor out that greatest common factor. So if I take each of these terms and I divide it by x, I would get 4x plus 3. In the second grouping, 8x and 6, the greatest common factor there would be 2. So I'm going to write down a 2. And then divide each of those terms by 2. 8x divided by 2 would be 4x. And 6 divided by 2 would be 3. Now, this method is working if these two things in parentheses are identical. So 4x plus 3 and 4x plus 3, they are identical. So I'm going to take that out as a common factor of this term. That's a loosely used terminology there. So taking out a 4x plus 3 from each of those things that I just put a bracket under. Do notice that I'm putting that in its own little set of parentheses there. And then if I divide each of those things that I put in a bracket by 4x plus 3, what would be left from the first one is an x, and what would be left from the second one is a plus 2. So the other factor is x plus 2. And this is now completely factored. Let's look at the second one on here now. So 6x squared minus 11x plus 3. See if I can find another color that will work here. I'm going to use red for my scratch work this time. Okay, so I'm going to start with scratch work on this one. I'm taking 6x squared and multiplying it by 3. So 6x squared times 3 is equal to 18x squared. So now I'm going to be looking for factor pairs for 18x squared, and I want them to add to make a negative 11. So my first factor pair would be 1x squared plus 18 1x plus 18x. And that would give me, when I add them together, 19x. I need a negative 11x, so 19x is definitely not the same as that. So I'm going to keep going. 18x squared could also be a 2x times a 9x. So I'm going to write 2x plus 9x because I have to sum the factor pair. So 2x plus 9x is 11x. Now my middle term is supposed to be a negative 11x, and this one came out to be a positive 11x. So I think I may not go through my whole list of factor pairs for 18x squared here. I think I may try to be smart about my work here. So if 2x and 9x add to 11x, then that would mean that a negative 2x and a negative 9x, I'm going to go ahead and write that down, would add to a negative 11x, which is what I need. So if a negative 2x times a negative 9x equals positive 18x squared, then I have the pair that I need. And a negative times a negative is positive, so this actually does work. So this is the pair I'm going to use. Let me go find a fresh color to work with for the rest of this problem here. So dark blue, perhaps. We'll be patriotic. Okay, so my first term stays the same. My middle term is going to be replaced with what we have here. So minus 2x plus minus 9x, and then the plus 3 from the original as well. Now once I've done that, I'm going to group together the first two terms and group together the last two terms, and I'm making sure that there's a plus sign between the two groupings. Now I'm looking for a greatest common factor in the first group. So between 6x squared and 2x, they have a 2x in common. So to find the other factor that goes along with that 2x, I would be dividing each of these original terms by 2x. So 6x squared divided by 2x would be 3x. And then 2x divided by 2x would be 1. On the second grouping, I've got a negative 9x and a 3. Now because the leading term in this one has a negative, whatever I take out as a greatest common factor, I'm going to take out a negative along with it. I will do that anytime the first term of whatever I'm factoring is negative. It makes everything a whole lot friendlier. So between 9 and 3, negative 9x and 3, the common factor would be a 3. And again, I'm taking out the negative because the first term is negative as well. So negative 9x divided by negative 3 would be 3x. And then 3 divided by a negative 3 would be a negative 1. Now this factor by grouping is working for me as long as these two things that are in parentheses are identical. And they are. So those two things that are identical, we call that a common binomial. I'm going to take that out as my common factor for these two groups. So if I take this first thing that I put a bracket under and I divide it by 3x minus 1, I get 2x. And if I take this thing that I put a bracket under over here and divide it by that common factor, 3x minus 1, I would get negative 3. So I'm just going to write that as minus 3. And this is now completely factored. Okay, there are two more examples here at the bottom, and I'd like for you to go ahead and try these. So at this time, you need to pause the video and try these two problems, and then come back and see how you did. Okay, so for the first one, the final factored form should be x minus 3 times 5x minus 1. And for the second one, the final factored form should be 2x minus 3 times 5x plus 1. Now, I do want to mention that the two factors that are being multiplied together do need to each be in their own set of parentheses. So if you're kind of a little lazy with your parentheses, this would be a great time to correct that.